Okay, so this is part 2 of our 3.5 notes on finding real zeros of polynomials. We left off the last video, example 1a, we found the real zeros of this polynomial by we have this polynomial over here, set it equal to 0, we factored it, and we found that we had zeros of -3 and 0. So I want to show you when I graph this, if I graph that polynomial, which if you look here, one second. I graphed the polynomial 3x to the 5th plus 18x to the 4th plus 27x cubed. And when I graph this, let me change my window here. I get a graph that looks like that. And my zeros are my x-intercepts here. So I have right here and right here. And if I trace, so, oops, not second trace, just trace, if I go to -3, which is one of the zeros, you can see that that is indeed an x-intercept. And then if I go to 0, you can see that that's the other x-intercept. Now notice something here, because we're going to be talking about multiplicity of zeros, which has to do with the fact that, notice that in one of these zeros, the graph crosses right through the x-axis, and it also has a little bend in it. And then this 0 touches and then comes back down. It doesn't cross through the x-axis, it just touches the x-axis, and that has to do with the multiplicity of zeros, which we'll get to in just a bit. Okay, so let's solve another polynomial here by factoring. All right, again, remember we want to find the zero, so we want one side equal to 0. So what I'm going to do, step 1, is I'm going to add 36 to both sides of this polynomial. So I have this equation. All right, so first thing we look for, is there anything common to all of the terms on the left side? And the answer is no. And now notice that we have x to the 4th minus 13x to the 2nd, and then plus 36. This is not quite a quadratic. It's in what's called quadratic form. Something is in quadratic form when our variable here, that's to the 4th power, and if this one is this is half of that amount, which is x to the 2nd power, and then we have plus a constant, that's called quadratic form. And so when I go about factoring this, instead of x and x being in the first two slots, I'm going to have x squared. And that's really, for this example, that's really the only difference between factoring if it was x squared minus 13x plus 36, like a quadratic, like we had up here. We're just going to have x squared at the beginning, and then everything else will be just like factoring a quadratic. So we're looking for factors of 36. So I'm going to factor this. Factors of 36 that add to -13. I want you guys to be thinking about it. Pause for a second and try to factor it. You should have gotten x squared minus 9 and x squared minus 4, because -9 times -4 equals 36, and -9 plus -4 adds to -13. Okay, so we are not done, because we have quadratics here, and we have a difference of squares, x squared minus 9. We have another difference of squares, x squared minus 4. So remember what those factor into. It's going to end up being x plus 3 and x minus 3. Hang on, my board is not keeping up with me. Okay, x plus 3, x minus 3. And then x squared minus 4 is going to factor into x plus 2 and x minus 2 and x plus 2. It doesn't matter which order you put those in, as long as one's plus and one's minus. So when you see a difference of squares, just remember there's going to be the square root of the first plus or minus the square root of the second term here. Okay, now we have 4 factors. We're going to set each factor equal to 0 and solve it to find our zeros. X minus 3 equals 0. I went out of order here, but still going to give me the same zeros. So if you solve each of these, you're going to subtract 3 from both sides, you get x is -3, that's 1, 0. Here we're going to get x is equal to +3 because we're going to add 3 to both sides. Here we're going to subtract 2 from both sides, you get x equals -2. And then the next one here is x equals, we're adding 2 to both sides, so it's x equals +2. So we have 4 zeros. So our zeros were, we had x equals -3, +3, -2, and +2. And if you look at this graph, this is what the graph looks like. I graphed x to the 4th minus 13x squared plus 36. For my window, I set the x from -10 to 10 and the y from -10 to 50 if you're following along with your graphing calculator. Now if I go to -3, you can see that that is an x-intercept. And we can trace to -2, another x-intercept, and then +2, another x-intercept, and +3. All of those are x-intercepts or zeros of the function. And those are real zeros because they are indeed x-intercepts. And they don't involve I. So why don't you guys try this C, and then so pause the video, try to factor. Remember to start by factoring out common factors, and then go from there. All right, so when you factor out a common term, the common term is 2x to the 4th, and what's left inside the parentheses is x squared minus 5x plus 6 equals 0. And then we still need to factor this trinomial here. Leave the 2x to the 4th because we need to keep all the factors and set each of them equal to 0 to find all the solutions. Factoring x squared minus 5x plus 6 factors in x minus 2 times x minus 3. And then set each factor equal to 0, and you should get x equals 0, x equals 2, and x equals 3. You can go ahead and graph this original function in y1 and trace to 0, 2, and 3, and you'll see that you have the x-intercepts at 0, 2, and 3. All right. Oops, hang on.